Hi friends, welcome to the Unit 3 Day 5 notes. We're going to be talking about vertical asymptotes. Vertical asymptotes are found by looking at values that give you a 0 in the denominator when you have a function written in the lowest terms. We talked about this in the previous video, but really knowing that when it comes from either a factor that cancels, or if you just have it without canceling, then you can find out if it's a whole or if it's a vertical asymptote. So So essentially in this case, vertical asymptotes are either going to be vertical asymptotes, or they could have a special case where we call them wholes. So a special case is a hole in the graph. So here we have two equations. Here we have rational functions, so we have a numerator, denominator. These are not simplified. We can simplify them. So what I'm going to do is I'm going to factor both of these. If I factor x squared minus 5x plus 4, looks like I've got factors of 1 and 1, factors of 1, 4, 2, 2. 1 and 4 is going to be the way I'm going to want to go for the numerator here. So this gives me y equals, I'm going to do x minus 4 and x minus 1. And then the denominator is a difference of squares. So that's going to be x minus 2 and then x plus 2. So in this case, you don't have anything that cancels. You don't have a factor that cancels the numerator and the denominator. So in this case, what you have is you just have a vertical asymptote. So remember, vertical asymptote and then a specific case is then the whole. So vertical asymptotes, and to find them, you just set your denominator equal to 0, and that tells you the equation of the line of the vertical asymptote. So if I set x minus 2 equal to 0, and then solve, I get x equals 2. If I set x plus 2 equal to 0 and then solve, I get x equals negative 2. So these are vertical lines, x equals vertical lines, and these are the vertical asymptotes for it. So the vertical asymptotes for this particular problem, which you'll see abbreviated VA, are x equals negative 2 and x equals 2. So these are these specific vertical lines. The graph does not exist at this particular point. Calling it a vertical asymptote, it's basically calling out at this particular spot in the graph, this does not exist. The graph does not exist. There's not a y value because we can't have a y value. For this example over here, number 2, the denominator is the same for this part. I'm going to use a different color so you can see it easier. Hopefully. So I have y equals, so in this case, zooming in also helps. So in this case, my denominator, as I said, it's the same. So x plus 2 and x minus 2. And then the numerator, so my coefficients for x, my coefficients for my constants factors, so that's going to be x minus 3, and then looks like x plus 2. So in this case, if you notice, what happens here is that I have a factor that cancels. The x plus 2 and x plus 2 cancels. So what happens here is you need to now take, this is a special case because it's canceling, this is going to give us a whole. To find the whole, we need to set this x plus 2 equal to 0, and then solve. So this negative 2, we plug back in to the reduced or simplified form to find the y value of the whole. So this is a hole in the graph. So I have y equals, if I plug that in, I have negative 2 minus 3 over negative 2 minus 2. We plug it in the simplified one because if I plug it back in the original one, I'm going to get 0 in the denominator. That doesn't tell us any useful information. So this I have negative 5 over negative 4. And then negative 5 over negative 4 just reduces down. That's 5/4. So remember I said this is my y value. This is a point. The whole is a point. Whole is a point. It's a point on the graph where it doesn't exist. On the graph where the graph is undefined. So with this particular graph, the whole here is negative 2, comma 5/4. So that's the whole. The whole on the graph is negative 2 comma positive 5/4, excuse me. And so there's still a vertical asymptote, because here the x minus 2, that didn't cancel, so I still have a vertical asymptote with the graph. The vertical asymptote for this graph is going to be x equals 2. So you have different, so in this particular scenario, in this particular case, what you have is you'll have a vertical asymptote and then also a hole. What I would recommend you doing is go ahead and graph this. I'm going to show you in my graphing calculator, but go ahead and practice graphing it first, so you can just see some common things that come up when you have graphs like these. If you get a chance, go ahead and pause the video now so you can go through and graph it so you can see what it looks like. I'm going to graph number 2. You can graph number 1 as well, but number 2 actually gives us a little bit more information because it gives us both a hole and a vertical asymptote. A lot of the mistakes that students make when they're plugging in their graph is they don't use parentheses. So we need to put parentheses around the numerator and the denominator, like so. And then when I go to graph, you'll see essentially your graph does squiggles like that. Now, it's very easy to tell from this graph where the vertical asymptote is. This is where the graph approaches infinity and then the y values approach negative infinity. That's what's happening there. But what about the hole? It's hard to see the hole at this graph. So remember I said the hole for this graph was at -2 and then 5/4. So what I did is I pressed trace. What trace does, if you've not pressed trace and you've just graphed, what trace will always do, it'll give you the y-intercept, so, or close to it. In this case, if I put in 0 for my x, I get a y value of 1.5. However, I want to check the -2, where x is -2. So I can just type in -2 and it'll come up with this box that says x equals -2. If I press enter, it tells me what y is. Remember, the y value, it doesn't exist. It's a hole in the graph. That's why your calculator is telling you there's nothing there. There is literally nothing there on this graph. It is a hole in the graph. Just like there's a hole in the road, or if you have a hole in your clothing doesn't exist. The road doesn't exist at that point. Cause damage to your car, that's bad. That's on my mind because I ran into a pothole this morning. Regardless, here what we have is an example of both a vertical asymptote and a hole. If I actually arrow over one to the left, you can see that the cursor actually appears because it's actually now on the graph. If I plug in that value, that's what I get. So I'm just going through and just showing the values. Now, I'm never hitting -2 again because the cursor that's going left and right, it's not going to hit -2. I actually have to type in -2 to see that that's a hole again. So kind of a big concept, vertical asymptotes, holes. Next video, we're going to now jump into horizontal or oblique and slant asymptotes. See you then.